In endpoint security, some tools are pretty straightforward, but others, they've got some hidden depths. And Symantec's host integrity, well, it definitely looks like a simple compliance checkbox, right? But what if that's just scratching the surface? What if I told you it's actually a super powerful, scriptable engine that can automate fixes and even be a key player in a modern zero-trust strategy? Let's dig in and find out what this thing can really do.
So, here's what we're going to cover. We'll start with the main idea, thinking of it as a digital bouncer. Then, we'll touch on the basic health checks that pretty much everyone knows. After that, we're going to peel back the layers and look at the logic engine that's really at its heart. We'll see how it can find and fix problems all by itself, how it plugs into a zero-trust world, and then a really important reality check on where it shines and where, well, it doesn't.
All right, let's kick things off with Section 1, the digital bouncer. Before we get into all the fancy advanced stuff, let's just make sure we're all on the same page about what host integrity even is. Okay, so here is the official textbook definition. At its core, host integrity is all about making sure the devices connecting to your network are playing by your security rules. It lets you define what a healthy device looks like, it enforces that standard, and it can even help fix a device that's kind of fallen out of line. That's a good technical definition, sure, but what does it mean in the real world for all the laptops and desktops trying to connect to your network every single day? The absolute best way to think about it is like a digital bouncer at a club. Before any laptop gets to access your network, your files, your apps, host integrity steps in and says, whoa, hold on a minute. It's checking its ID. It's asking, is your antivirus on? You got the latest security patches? Is that firewall running? And only if it gets all the right answers does it get to come inside. And that whole bouncer idea leads us right into its most common job, just running those basic, out-of-the-box health checks that most of us are familiar with. So when you go to build a policy, this is probably what you're used to seeing. The add requirement screen. It's a simple list of predefined checks, and for most people, this is really the bread and butter of host integrity. And those options cover all the essentials, right? You can quickly build a policy that checks if your antivirus is installed and up to date, if a specific critical patch from Microsoft is there, if the firewall is on, or if the OS is on the right service pack. It's simple, it's effective, and for a lot of folks, this is where the story ends. But really, it's just the beginning. Okay, now we get to the really powerful part. We are leaving those simple checkboxes behind and looking at the core of host integrity, a full-blown logic engine. See, what's actually running the show under the hood is a scriptable logic engine. And this means we're not just taking boxes anymore. We're getting to create our own custom rules using basic programming logic. If some condition is met, then do this specific action. Else, do something different. This is where it gets incredibly flexible. And when you open up that custom requirement editor, you see that logic in action. Okay, I know, this looks super intimidating. It's just a wall of nested commands and functions. But here's the secret. All of this complexity is actually built from just a few very simple, very understandable pieces. These are the building blocks. The if statement just checks for something. Is a file there? Is a registry key set right? Then is just what happens if that check is true. And else is the backup plan. But the real magic comes from and or, because they let you chain these checks together. So you could check if, say, patch A or patch B is installed, which is perfect for those times when a security update gets replaced by a newer monthly rollup. So we can build some pretty complex logic to find problems. But what about fixing them? This is where host integrity goes from being a passive checker to an active, automated repair tool. And this workflow, this is where the real magic happens. Think of it like self-healing for your computers. First, your if statement detects a problem. Maybe a piece of software is missing. If that check fails, the script can then automatically go and download the right installer from a server. And finally, it executes that installer to fix the problem, bringing the machine back into compliance without a single person ever having to touch it. Now, you gotta look closely at the screenshot. There's one tiny but absolutely critical detail here, the in-system context option. This is the secret sauce. This little checkbox lets the script run with the highest system privileges, completely bypassing any user permission issues. What that means is, even if the person using the computer isn't an admin, the fix gets applied silently and reliably in the background. For any IT team out there, that is a total game changer. So this deep inspection capability is really powerful on its own. But you might be wondering, how does an older tool like this fit into a modern security model? Well, that brings us to zero trust. So back in the day, if a host integrity check failed, it meant one thing: quarantine. The agent would use the local firewall to basically lock the device down. But in a modern zero trust world, where you don't automatically trust any device, the approach is different. Instead of quarantining, the agent just reports compliance. It sends a simple pass or fail signal up to a central decision maker, like a cloud security broker. The enforcement now happens out at the network edge, not on the device, and the result is so much smarter. Instead of a total block, you get these fine-grained decisions, like blocking access to just one specific app while leaving everything else alone. And here's what that looks like in the management console. That simple pass or fail status becomes a live, real-time signal. And that signal is exactly what a ZTNA, or a Zero Trust Network Access, solution needs to make smart decisions. All of a sudden, access isn't just about your username and password anymore. It's about the real-time health of the actual device you're using at that very moment. Okay, we've talked about some incredibly powerful features. I mean, this stuff is really cool. But, and this is a big but, it's absolutely essential to have a reality check because not all of these amazing capabilities are available on every single platform. And this table here, it lays it all out pretty clearly. All those amazing features we just went over, the deep custom scripting, the automated file downloads and remediation, even that old school local quarantine, they're all pretty much exclusive to Windows. When you move over to macOS, host integrity is stripped way back to the basics, like checking AV status or if a specific process is running. And hey, don't just take my word for it. The source documentation puts it pretty bluntly. The Mac version just doesn't have the deep system inspection and, critically, the automated remediation that makes the Windows version so powerful. It's a key distinction to remember when you're designing your security policies across all your different operating systems. So let's wrap this all up with the key takeaways. First and most importantly, stop thinking of host integrity as just a checkbox tool. It's a powerful, scriptable logic engine. Second, you can use that engine to build self-healing workflows that literally automate detection and repairs. Third, it has this whole new life as a critical device posture signal for any modern zero trust strategy. And finally, just remember that all this advanced power is almost entirely focused on Windows. And that kind of brings it all into focus. So I'll leave you with this question. Now that you know what this engine can really do, from its deep logic to its automated fixes, what is the one security gap in your environment? That one manual repetitive task that you could finally automate away? Thanks for watching.